So where we left off yesterday was this problem here. So we finished up this problem, and now we're looking at this one here. So we're wanting to solve this higher degree polynomial function, 2x to the fifth plus 24x equals 14x to the third. And whenever we're solving higher degree polynomial functions, we need the equation equal to 0. So for this one here, because it's not equal to 0, we need to make it be equal to 0. Now, we can do it in two ways. One is we can move the 2x to the fifth and 24x over to the 14x cubed. Or the easier way is to just move the 14x cubed over to everything else. And we can move the 14x cubed by subtracting it from both sides. Now, since 14x cubed does not have any like terms on the left-hand side, the left-hand side just becomes 2x to the fifth minus 14x cubed plus 24x is equal to 0, because our 14x cubed minus 14x cubed is 0. And whenever we're solving these here, we do need to get it equal to 0. Unlike quadratics where we had some where we didn't have them equal to 0, but we could still solve, all of our higher degree polynomials, when we start these off, we do need them equal to 0. Now our next step, like some of the previous ones, we're going to type it into the calculator. Clear both of those out. So the first thing we're going to do is hit y equals. And then we're going to type this in, 2x to the fifth minus 14x to the third plus 24x. Questions on how we type this in? And make sure we type them in so we get some practice typing them in so that we are ready, especially for the test, being able to type them in. Once you get it typed in, hit graph. Once you get it typed in, hit graph. Two x to the fifth. Minus 14x cubed plus 24x. Everybody get something that looks like this here. Now we do see that it crosses the x-axis in 1, 2, 3, 4, 5 places. So that means we should have 5 solutions, because every time it crosses the x-axis, we do have a solution. And if it just touches the x-axis, we would have multiple. But 3 of the solutions that we can see here are -2, 0, and 2. Because again, when we're finding solutions, we're trying to find out what value of x will make the y value be 0. Now this one here, when x is 0, y is also 0. So it includes it as a solution. So the solutions we know so far is that x is equal to 0, x is equal to -2 and 2. So we have a total of 3 solutions. And that's helpful because with these 3 solutions, we can bring the degree of this down by 3, from a degree 5 to a degree 4, from a 4 to a 3, and then a 3 to a 2. And we can solve a degree 2. Now to bring the degree down, we have to do synthetic division. The numbers going across the top would be 2 for x to the fifth. Since we don't have an x to the fourth term, we fill it in as 0. -14 for our x cubed, 0 for x squared, 24 for x. And since we do not have a constant term, a number without a variable, we'll fill it in as 0. Questions on this so far? Now, out of the three solutions we have, which one do we want to try first? 0, -2, or 2? -2. And we'll go through the synthetic division process. So we'll do -2 times 2 is -4. 0 plus -4 is -4. -2 times -4 is 8. -14 plus 8 is -6. -2 times -6 is +12. 0 plus 12 is 12. -2 times 12 is -24. -24 plus 24 is 0. -2 times 0 is 0, and 0 plus 0 is 0. Since we found this to be a solution when graphing, we know the remainder had to be 0. Okay. We did have another solution. Which one do we want to do next? And we repeat the process. 2 times 2 is 4. -4 plus 4 is 0. 2 times 0 is -6 plus 0 is -6. 2 times -6 is -12. 12 plus -12 is 0. 2 times 0 is 0. And 0 plus 0 is 0. So again, we found out the remainder of 0, which is what we expected because we know it is the solution. Now that's brought it from a degree 4 polynomial function down to a degree 3. Well, we didn't start out at 4. We started out at 5. Degree 5 to a degree 4. We brought it from a degree 4 down to a degree 3. And if we do this one more time, we'll have it down as a degree 2, a quadratic, and we can solve from there. Now, there's only one other solution that we found that we haven't used yet, and that was 0. 0 is actually sometimes the easiest one to use because 0 times 2 is 0 plus 0. 0 times 0. -6 plus 0. 0 times -6. 0. And 0 plus 0 is 0. So we now have it as a quadratic. Now at this point here we can try -2, 2, or 0 again, but unfortunately none of those work. Because if we tried this with 0, bring down the 2, 0 times 2 is 0, 0 plus 0 is 0, 0 times 0 is 0, and -6 plus 0 gives us -6. We have a remainder other than 0, so it is not a solution. If we tried this with 2, bring down the 2, 2 times 2 is 4, 0 plus 4 is 4, 2 times 4 is 8, -6 plus 8 is 2, we have a remainder other than 0. But if we put the variables back in, 0 is our remainder, -6 is the term without x, 0 is our term with x, and 2 is our term with x squared. So what we're left with is 2x squared minus 6 equals 0. Now, since this is a quadratic with no middle term, we can use the square root method. And the first part of the square root method is to get the term being squared, our x squared, by itself. So the first thing we can do is add 6 to both sides. Then we'll divide both sides by 2, telling us that x squared is equal to 3. And lastly, we'll take the square root of both sides. Square root of x squared is x equals plus or minus. We're looking at the square root of 3. 30xs will simplify radicals for us. And if we plug in the square root of 3, it tells us it is square root of 3. So it doesn't reduce, which means it's just the square root of 3, plus or minus the square root of 3. So we do have those two solutions there, and we still have our -2, 0, and 2. So for this problem here, we have a total of 5 solutions. Questions on this here? Questions on anything we've done so far today? Now, for the most part, this kind of picked up from where we left off yesterday, and we can see with graphing and this here, we can find most of the solutions, especially if it gives us 3, in this case, integers. We're able to use synthetic division, get it down, and solve from there. Now, the issue arises is if not all of them are nice integers, but are rational. Now, we do have this theorem here, and this theorem is actually quite helpful, the rational zeros theorem. And what this says, and the main part that I would especially have down is this part here, P over Q. Really will say plus or minus P over Q, where P is the factors of the constant term, the term without x, and Q is the factors of the leading coefficient, the number in front of the variable with the biggest exponent. And this here, P over Q, will give us all of the possible rational zeros that we could have. So if a polynomial function has rational zeros, this equation here, plus or minus P over Q, will list them out. It will give us all the rational zeros. So we're going to look at this one here. Find its rational zeros are plus or minus P over Q, and then solve it from there. Now looking at this here, P is all of the factors of the constant term. P is all the factors of the constant term, the term without x. And our constant term in this case is 20. So we're looking at what multiplies together to give us 20. Well, we have 1 and 20. What's our next one going to be? 2 and 10. 4 and 5. So that's all of our factors of the constant term. Now we need the factors of the leading coefficient, the number in front of the variable with the biggest exponent. 1. Well, all the factors of 1 are 1. It's just 1. Now for this here, what we're going to do is take each of the factors of P and divide it by each of the factors of Q and add plus and minus. So the first one that we'll have is plus or minus 1 divided by 1, which is 1. Plus or minus 2 divided by 1 is 2. Plus or minus 4 divided by 1 is 4. 5 divided by 1 is 10 divided by 1 is, and 20 divided by 1 is 20. And for any of these here, with our rational zeros, we will have plus or minus pretty much all the factors of P, because when we divide by 1, we just get the number back. However, if there had been another factor of Q, say, I'm going to pick one, 4, it wouldn't just be 4, but let's just say 3. Then I would start the process again. We'd do 1 divided by 3, 2 divided by 3, 4 divided by 3, 5 divided by 3, 10 divided by 3, and we just keep going through until we get them all listed. So, questions on how we found the rational zeros? We feel good with these here? All right. I'm going to erase this for now, just so I have a little more room. So what we've said are these here are all the possible rational zeros. So we can do synthetic division on each one of these here. So 1 for x to the third, negative 8, 11, and 20. We bring down the 1. Well, the first one we have listed is 1, yes? So let's do this here. 1 times 1 is negative 8 plus 1 is negative 7. 1 times negative 7 is 11 plus negative 7 is 1 times 4 is 20 plus 4 is that the remainder that we wanted? No. So is 1 a solution? No. Okay. Well, now we can erase all that there. Since 1 didn't work, we can try. Well, yeah, we can try 2. And do this again. 2 times 1 is negative 8 plus 2 is 2 times negative 6 is negative 12. 11 plus negative 12 is 2 times negative 1 is that the remainder we wanted? No. Okay, well. Yeah. Negative 1 times 1 is negative 1. Negative 8 plus negative 1 is negative 1 times negative 9 is 9. Question? Because positive or negative 1 is one of the rational zeros, positive or negative 2, positive or negative 3, because our plus or minus. So we picked 1, it didn't work. We picked 2, it didn't work. So now we're just trying negative 1, because it is a possible rational zero. And we get to this step here. 9 plus 11 is 20. Negative 1 times 20 is negative 20, and 20 plus negative 20 is 0. So that told us one of the solutions for this here is that x is equal to negative 1. Now at any step, if a solution doesn't work, it's not going to work in any of the following. So since 1 and 2 did not work originally, they're not going to work at this step here. So with 1, negative 9, 20, if we tried 1 or 2, it wouldn't work. So that means for us that the numbers that are out, x cannot be positive 1 or positive 2. Now negative 1 could work again, or negative 2, or 4, negative 4, 5, negative 5, 10, negative 10, 20, or negative 20. Well, do we want to keep trying those? Because we could do that, or we could turn it into a quadratic, or from the beginning, I got to type this in as x to the third minus 8x squared plus 11x plus 20. Graph. Second table. That tells us negative 1 is a solution. But it also tells us 4 and 5 are solutions. So it could have taken us a little while to get to 4. And we try this here. 4 times 1 is 4. Negative 9 plus 4 is negative 5. 4 times negative 5 is negative 20, which does indeed give us a remainder of 0. Leaving us with the equation x minus 5, because when we plug the variables back in, remainder, our negative 5 is our term without x, 1 is our term with x. And if we solve, we do get that x is 5. So our solutions are that x is 1, x is 4, and x is 5. So here it worked out nicely that we got 3 nice whole number answers. But it does give us an idea of where to look, what values will work. Questions on this here? I'm going to skip the next two. I want to get to this one here, because I want to get to some zeros, rational zeros that aren't just purely integers. Or plus or minus P over Q. So we want to solve this here. Let's find the rational zeros first. Yep. Need a pencil? So P, values of P are going to be the factors of 12. Well, we're going to have 1 and 12. 2 and 6. 3 and 4. So I put a little more space than was absolutely needed. But these are all the factors of P. Q, factors of the leading coefficient. We're looking at factors of 10. And that's it. Questions on how we found factors of P, factors of Q, values of P and Q. Now the first thing we're going to do is divide all of our values of P by 1. Which, just like the last one, 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6. And 12 divided by 1 is 12. So whenever we do our first division, the division with 1, we just get all the values of P back. Now what we're going to do next is divide each of the values of P by Q. So when we do 1 divided by 2, we get 1/2. And if we can reduce it, we're going to reduce it. Our next one is 2 divided by 2, which is 1. We already have it. If we have it already, we don't have to write it again. Our next one is 3 divided by 2 is 3/2, because 3 does not divide by 2 nicely. The one after that is 4 divided by 2, which is 2. We already have it. We don't need to repeat it. 6 divided by 2 is 3. It's already listed. We don't have to repeat it. And lastly, 12 divided by 2 is 6. It's already up there. All right. Now we're going to move on to the next one, which is 5. So we're going to start off with 1 divided by 5, which is plus or minus 1/5. Then we'll have 2 divided by 5, which is plus or minus 2/5. 3 divided by 5 is plus or minus 3/5. 4 divided by 5 is plus or minus 4/5. 6 divided by 5 is plus or minus 6/5. And lastly, 12 divided by 5 is plus or minus 12/5. Let's go here. Questions on this here before we look at 10. Now again, we're going to repeat this process. So we're going to do 1 divided by 10 is plus or minus 1/10. 2 divided by 10, well, 2 and 10 do have a common factor of 2. And again, we could be doing these in the calculator. 2 over 10 is 1/5. We already have 1/5 listed. 3 over 10. 3 over 10. 3/10. We do not have it, so plus or minus 3/10. We move on to 4/10, which is 2/5. It is already listed. 6/10. It is 3/5. We already have it listed. And I believe the last one is 12/10, which is 6/5, which is already listed as well. So these here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16 times 2 because positive, negative. We have 32 possible rational zeros. And only 4 of them, there's only 4 possible zeros. At most, 4 of these 32 will work. At most. At least, none of them work. Now, instead of going through the arduous process of trying these one after another, why don't we graph it first? 10x to the 4th. Clear all that out. 10x to the 4th. Minus 11x to the 3rd. Minus 42x squared plus 7x plus 12. So we do see that it crosses the x-axis in 4 places, yes? Second graph. Well, none of them are at nice numbers. So we can say for certain, well, 1, -1, 2, -2. All these here. Let's get this color. Not what I wanted. 1 and -1 is out. 2 and -2 are out. 3 and -3 do not have 0. 4, -4 don't have 0. And really, if we went on and looked at 6, -6, it does not work. Calculator. 12, -12 does not work. And if we scroll down, 12 doesn't work. So what it's told us is none of these here work. None of these solutions work. But if we look back at the graph, we do see 4 spots that it does cross. Yes? Now we do have one of them between 0 and -1. Yes? So if we look at all these here, I'm going to get a highlighter. All the ones between 0 and 1, well, -1/2 would be between 0 and -1. 3/2, well, that's greater than 1, so that doesn't work. -1/5 would work. -2/5, -3/5, -4/5 would work. 6/5, 12/5, that's bigger. And then we have our -1/10 and -3/10, yes? Now, 3/5 is a little bit greater than 1/2. 4/5 definitely should be closer to -1 than 0. But out of all these here, we can try -1/2 first. Yes? Now, something that is interesting with this graphing calculator, hopefully you have it typed in and turned on. If we go second trace, the one next to it, what is the first option we get? Value. Hit enter. what this is asking us to do is it's asking us to input a value of x. Well, we want to try negative 1/2, yes? So we can do negative 1 alpha, let's enter, well, divided by 2. Unfortunately, it won't let us do the fraction form, just numerator divided by denominator, so negative 1 divided by 2. And if I hit enter, it'll tell me its corresponding y value, which is 0. Is that what we're looking for? Yes. So it tells us, firstly, that x is equal to negative 1/2. And we can go on and do the synthetic division. 10, negative 11, negative 42, 7, 12. We can bring down the 10. Negative 1/2 times 10 is negative 5. Negative 11 plus negative 5 is negative 16. Negative 1/2 times negative 16 is going to be positive 8. Negative 42 plus 8 is negative 34. Negative 1/2 times negative 34 is going to give us positive 17. 7 plus 17 is positive 24. And negative 1/2 times 24 is negative 12, giving us a 0. Now, since it does cross the x-axis at negative 1/2, there's a good chance it's not going to work again. So now we're looking at one of our other points. So we're between 0 and 1, closer to 1. So we could try, say, 3/4 or 4/5. Again, we can do the same thing. Second trace value, 4 divided by 5. Did that give us a value of 0? No. So we can exclude it. Second trace value, 3/5. Yes. Now we don't even have to look at negative 4/5 or negative 3/5 because negative 4/5 and negative 3/5 are between 0 and negative 1. We already found the one solution, so they don't work either. But our next one we can try, and let's get a color other than this yellow, is 3/5. Now again, most of this calculation that we're doing with the synthetic division, you can do these in a calculator. 10 times 3/5 is 6. Negative 16 plus 6 is negative 10. 3/5 times negative 10 is negative 6. Negative 34 minus 6 is negative 40. 3/5 times negative 40 is negative 24, which gives us a 0. So we have these two here. Now we can try the rest of them, and unfortunately, none of them work because our other two values, one of them is between 2 and 3, and the other is between negative 2 and 3. Well, all of our values are actually between 0 and 2 and 0 and negative 2, so none of the rest work. So what we have to do at this point is plug the variables back in. 0 is our remainder, negative 40 is our constant term without x, negative 10 is our term with x, and 10 is our term with x squared. So we have 10x squared minus 10x minus 40 is equal to 0. One thing I will say, at any point in solving, if there is a greatest common factor, especially a number, get rid of it. Is there a greatest common factor between these three terms? 10. If it is a number, we can divide it out completely. If it is a variable, we have to factor it out front, because dividing by 10 is fine, and it will give us 10x, or just x squared, minus x minus 4 is equal to 0. And at this point here, we can't factor. We actually have to go back to our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b, well, our b value is negative 1. I don't know, I'm trying to square this. Plus or minus the square root of negative 1 squared minus 4. Our a is 1, c is negative 4, all over 2 times 1. Now our negative 1 becomes positive 1. The denominator 2 times 1 is 2. Now we do need to simplify what's inside our radical. So in the calculator we can put in our parentheses. Negative 1 squared minus 4 times 1 times negative 4, and let it do that for us, which is 17. Square root of 17 doesn't simplify, and that is as simplified as it gets. And we also have that x is 3/5 and negative 1/2. So it works out these are the 4 solutions for this here. And y'all go